Now the speed problems deals with this formula, which is rate times time equals distance. This is a standard formula that you basically know about because most of you drive cars, and you drive a car on the turnpike and you want to go to Boston, and your car is, your cruise control is set for 60 miles per hour. And that's the speed of your car, that's your rate. And if you travel that speed for 2 hours, so the rate is 60, the time is 2, you've traveled 120 miles. So you're used to that. That's your basic formula for doing these speed problems. So when I see a speed problem, I put that down on my paper. Now we've got a couple of things that we need to look at. We've got passenger trains and we've got freight trains. Okay, and so let's take a look at this. We need to make a little table of these words have to translate into algebra. And so let's take a look. We've got what's the slower of the two? I guess the freight train is the slower of the two. And then we've got the passenger train. I'll put right below it, F and P. The speed of the passenger train is 20 miles per hour faster than the freight train. Okay, so if you read the entire sentence in the second sentence, basically we don't know what the speeds are. So what I'm going to do is say, well, I'm going to make the speed of the freight train X, because I really don't know what it is. That's what we're trying to calculate. Mm-hmm. All right, and right below, they say in that first sentence, the speed of the passenger train is 20 miles per hour faster than what the freight train is. Okay. If the freight train's X, the speed of the passenger train is X plus 20. That's the speed of the passenger train. I'll make a bundle out of that. Okay. So, all right. The train travels 20 miles, travels 290 miles in the same time. So basically this T is the same. I don't know what the T is. I don't know if it's 2 hours, 3 hours, 3.5 hours. But it's the same value. I do know that if I did the multiplication out of these two quantities, the passenger train goes, the passenger train down here. Make sure you put the number right where it is. Should be 290 miles. And then we've got the freight train, which goes 190 miles. And there's the physics of the problem right over there. That's the physics of the problem. We've got the equations. So how do you solve these equations? And you take a look at it. We have two variables, x and t, x and t. The t's are the same. It says at the same time. So this variable really isn't a variable. It's basically at the same time. So if I were to solve this top equation for t, in other words, I want t equals. Okay, so come down here and say t equals 190 divided by x. Okay, that's what that is. So x times t is 190, solving for t, so divide both sides by x. Now, if you divide both sides by x, the x's cancel. Okay, and so that's what you end up getting here. And if I do the same thing over here for the second equation, t would equal, well, solving for t, I need to divide out this bundle. This bundle needs to divide out, but whatever you do on one side, you do on the other. So that's what I would do here. Let me put it in the center. Put that in the center, move this over here. So I guess I'll put that down here. The 290 over x plus 20 bundle. Okay, and we're almost done. These two t's are the same, so these two fractions are the same. That's what you end up doing. So so these two guys here, this is an equation I'm going to lay out horizontally. I'm going to make it look like this. Equals 290 x plus 20. All right, and now the rest of this is is basically some math. Where's my calculator? I got my calculator right over here. Where's my phone? Okay, here it is. I'll do my phone here. So what you're going to do, this is a proportion, right? What you're going to do is you're going to do cross multiplication. This times this equals this times that. So 290 x equals 190 x plus 20. And so let's get rid of the parentheses. 190x plus 3800. 190 times 20 equals 290 x. Okay, now solve for x. I get 100x equals 3800. Divide by 100, I get x equals 38. Now we did all this nice work, right? Did all this nice work. It'd be a shame to put that x in the wrong spot. We got two spots to put it in. What's x supposed to represent? X is supposed to represent the freight train. Look over there. See, you would probably put it over here because it's the first box, but nope. It's the freight train. I'll put the 38 in there. And the passenger train, if you know it's 38, the passenger train's got to be 20 more, 58. Check your answer. There you go. We got a fantastic. Super duper. We got the fantastic. How's it feel?
It's good. It's good. Yeah.
Okay. How about the other people?
I'm kind of lost, but I'll pick it up.
Why you're lost? What's going on? Why are you lost?
I don't know. I just, excuse me, I'm sorry, I have a sore throat. I got lost when we started doing the t equals 90 over x, and then the t equals 290. So yeah, that's
these two t's are the same.
Mm-hmm.
Okay, so what we want to do is solve for t in both equations. So if I were to solve for t, xt equals 190. I mean, if this was 5t, and I want to solve for t, you would divide by 5, right?
Right.
Whether you have an x or a 5, you still divide by whatever's in front of the t, which would be x. So you divide both sides by x, t equals this. Same thing here, t is equal to this, t times this bundle. I don't want that bundle near the t. I just want that bundle gone. If t is being multiplied by that bundle, you divide by that bundle both sides. So when you get to this point, you say the two t's are the same, so the two fractions are the same. If the two fractions are the same, lay them out horizontally so that you get your cross multiplication. And
I got lost in the canceling of the x plus 20 over the x plus 20. That's where I messed up, but I see it.
Okay, good. Good. Well, we got another one to do.
Oh, yeah.
Another one to do. File, new. Well, I don't want this. No, clear it. I don't want that.
Cancel.
Where the hell cancel? I don't want that. File. I'll just close this out. Cancel. Oh, geez, I'm losing my mind. File, don't save. Okay. File, new. Get a new blackboard here. Okay. All right. We got that. Move this over here. Let's go on to the next problem. Next problem. Okay. And now we've got planes, huh? Pilot flies 625 miles with a tailwind of 20 miles per hour. And against the wind, he flies only 525 miles in the same amount of time. So what's the speed of the plane? So basically what's happening is you've got this plane. Those are the plane. That's supposed to be a plane. Okay. The wind is pushing the plane. Okay. The plane naturally wants to fly a certain amount of a certain speed. A tailwind means you got 20 miles an hour. This 20 mile an hour wind is pushing the plane even faster than what it wants to go. So if the speed of the plane was 500 miles an hour, then relative to the ground, it would be going 520 miles an hour. Okay, that's what That's what that tailwind means. So that makes sense. I mean, if the wind is pushing it, you're going to go faster. And then if the plane's going in the opposite direction, if your plane's going in the opposite direction, see if I can make a plane. There's your plane. Going in the opposite direction. Okay. The wind is going against it. Okay. So the wind naturally wants to slow that plane down. So pretend there was no wind, and this was going 500 miles an hour relative to the ground, your plane's going 500. But if there's a 20-mile-an-hour wind pushing against the plane, it slows it down, so it'll be 480 miles an hour. That's relative to the ground. So that's basically what we're trying. This is how you write out your equations here. Okay, so let's write this down here. Let's do rate times time equals distance. Equals distance. That's my starting point. So now we need to come up with two equations. This is with the wind, W with the wind, and this is against the wind. Okay, those are your two equations that we need. And so what with the wind? So naturally, what's x? We need to come up with a variable speed. So x is going to be the speed of the plane without any wind. That's basically what I need to start off with. X is the speed of the plane. If there was no wind, then that's how fast the plane goes. But with the wind, it would be going x plus 20 bundle. Okay. Against the wind, the speed of the plane is whatever x is minus 20. Okay. Now, let's see. Against the wind, you fly in the same amount of time, So in other words, take that rate, multiply by t, same time equals. So with the wind, he goes 625 miles an hour, 25 miles, not hour per hour, 625 miles. And he flies only against the wind, he goes slower, so he has to go less distance. Okay, there it is. Those are your equations. Okay, if you don't have faith on those equations, then we can't proceed. We need to have faith in those equations. Anybody have a problem with those equations?
No, it worked for me. It works for me.
Anybody
I'm
else?
good.
Nope.
No, good. Oh, no, yes or no? You have faith?
Yeah, I'm good. We're good.
Oh, okay, you're good. Okay. Now we got to solve those equations. Same deal as the other thing. T's are the same. The T's are the same. So if I solve for T, I want T equals for the top equation. What I need to do is divide both sides by this bundle. So what I'm going to do is say T equals the 625 divided by that bundle. Okay. And over here, this T, right over here, I'm going to divide by this bundle, x minus 20. So this is going to be 525 divided by that bundle, which I might as well put the bundle, the parentheses, right over there. Okay. The T's are the same. That means the fractions are the same. So these two things are the same. These must be the same. Let me push it up in the middle. Okay. So what we got here is 625 divided by the bundle equals 525 over the bundle. Okay. Now the rest is, you should be a machine. Just be a machine and bang this out. Cross multiply. Cross multiply. I'm going to cross multiply that. See, so this times this is 625 times x minus 20 equals 525 x plus 20. Now, We got to get rid of those parentheses. So let me get my calculator going here. Where's my calculator? Calculator right there. So what I need to do is say, multiply it through the parentheses, 625 x minus 625 times 20. 20 times 625 equals 12,500 equals 525 x plus 525 times 20. So 525 times 20, 10,500. And let's see, I guess we'll subtract 525x from both sides, giving me 100x equals, and then I'm going to add 12,500 to both sides. So that would give me 2,300, 23,000 rather. So subtract 525x from both sides, you get this. And then we want to add 12,500 to both sides, giving you that. And then if I divide by 100, which is easy to do, I get 230 miles an hour. 230, and that's it. That's 230. That's how fast the plane goes. Normally. Check your answer. Great job. Now, I wouldn't obsess about these. If these problems are still bugging you, I wouldn't get too nervous about them. Just pass them. Just get past it. There's only going to be, on any test, there's only going to be one of these anyway, so you can still get a 95. And you can still get an A.
Mm-hmm.
All right, so what do you think? All right,
Well,
the next
okay.
problems are easy. These problems over here. Once you go, after you're done with the, what do you call that? With the speed problems, the rest of these are a piece of cake. Let's clear this off. File. Oh, let's close it. Close it. Don't save. File new. Okay. Let's go over here. Okay, now they're saying these are similar triangles. Similar means they look the same, only one's smaller than the other. Basically, they're saying they're in proportion. And you could tell by looking at this, if these are the corresponding sides, these are the corresponding sides over here. The right sides, we have the left sides, we have the bottoms, and we can set up a proportion very easily. If we take the small side, 5 over the corresponding big triangle, 5 over 10, that's equal to, so we take the small over the big, that's, so you have to be consistent, small over big of the corresponding sides is equal to, now we'll take the right sides. The right side is got a value of y, so the small here divided by 6. I mean, this is a breath of fresh air compared to what we just did. All right. If we do cross multiply, I get y equals 3. And that should be the answer for that. So that should, I mean, if you understand the speed problems, these should be no-brainer. But this next guy is actually a pretty useful a problem if you want to measure how high something is. So how high is a tree that casts a 12-foot shadow? This I don't like the way that the number that I'm going to get is a stupid number. So let me just go ahead and I want a better answer than that. Final check. Okay, give me a similar question. Jeez, still
It's going to be 42 anyways.
Yeah, I want a better answer than this. Similar question. Okay, there it is.
Yeah.
How high is a tree that casts an 18-foot shadow at the same time a 9-foot pole casts a? Oh, it's still the same thing.
Yeah, it's going to be 18 now.
Yeah, the 18. That's really not a good question. I don't know who wrote these things. The idea is this. You want to measure how high a tree is. Well, I can't climb trees anymore. I can't do much of anything anymore. Okay? And so let me make up my own numbers. Here's a tree. Okay, I don't know how high that tree is, but the sun is shining. It casts a shadow of, let's say, 10 feet. 10 feet. Okay? So how big the tree is X. All right, there's a triangle here. There's a triangle over here. So here, near the tree, same sun, same angle. Okay, same sun, same angle. We say that this has got a 2-foot shadow, and the pole is 5 feet. Now, certainly we can measure a pole that's 5 feet. There's not much you can do. You don't need any special instrument for that. But so you could take a tape measure and measure 5 feet here. We can take a tape measure and along the ground to get 2. But you're not going to take a tape measure and climb the tree. You'll fall out of the tree. So here's what you're going to do. It's the same thing as the similar triangles here. So what we're going to do is take this is one big triangle. Take the vertical sides. X over 5 equals, that's big over small, corresponding with 10 over 2. 10 over 2. Okay, along the ground here. And so if I do this, I get 2x equals 50. And divide by 2, I get 25. So 25 feet isn't much if you walk along the ground, but if you had to climb a tree, 25 feet is kind of high, especially when you're looking down. And it's dangerous. So that's a quick Boy Scout way of measuring heights, using the sun to help you out. Okay, so what do you think? I think we're done. Chapter 7 is the hardest chapter. It's the hardest chapter. You're going to like chapter 8. You're going to really like chapter 8 because it's a lot easier. So let me show you what I'm talking about with chapter 8. So I'm going to do chapter 8:1. Chapter 8:1. Okay, come over here, chapter 8:1. So there, now you're ready. Okay, we did this. You should be able to bang out quiz 7C, bang out the exam 2. Now